Now I have something really kind of fun for you to watch, a really life example where we're going to look at a Porsche versus a Volkswagen Beetle in a way you might not quite imagine. And then we are going to apply, after the video is over, we're going to apply our kinematics equations and analyze the motion of these two vehicles and see how it all works out.
So here we are, and I think I know where you think I know this is going. You're thinking the Beetle now has a twin-turbo V8 engine in the back, but no, same miserable configuration as always. No, the producers reckoned that all the Beetle would need to win a drag race with the Porsche was a bit more gravity. Let me explain. The helicopter is going to suspend our Beetle exactly a mile above the finish line here. At the start of the race, the helicopter will release the Beetle and it will begin its race towards the checkered flag. At the same time, I will unleash the Porsche from a mile away in this direction and the race will be on. Best predictions at the moment. The Porsche will complete the mile in 37 seconds. The Beetle somewhere between 36 and 40 seconds. The maths, which is done entirely by me and not at all by the Doctor of Aerodynamic and Automotive Sciences at Loughborough University, state that this really should be very close indeed. The Porsche can hit 62 miles an hour in 3.7 seconds. The one problem we do have is wind. Anyway, take my word for it, it's going to be close. It was time to take our positions. I don't think I've ever been so worried about wind speeds before. Just a 5-knot breeze could alter where the Beetle will land by half a kilometre. And that's slightly scary. Hello, what's the latest wind speed?
Wind speed 6 knots.
Will you just climb into 4,040?
Not exactly sure what use the crash helmet's going to be if, but it's a nice touch. Soon, the Beetle was hovering 1 mile above the finish line.
Lining up for the drop. Stabilise, load.
I'm ready.
3, 2, 1.
We're off! Seconds. I should be doing 60 by now. I'm at 45. This surface does not react the same as tarmac. 7 seconds in, he's doing 100 by now. I'm doing 75. With the Porsche struggling to accelerate on the slippery salt flats, the Beetle was romping into the lead. Look at him tumble! I'm doing 100 miles an hour. It's moving about on the salt. It's a terrible surface. But the Porsche wasn't beaten yet, because at 125 miles an hour, the Beetle reached terminal velocity and couldn't fall any faster. Whereas my Speedo could keep climbing. I've got to keep pushing through. 125 for me, we're matching speed. He's rolling about all over the place. 140. 145. No! God, I lost! No! Not the Beetle! Well, my life is over. On the plus side, I think the Beetle looks in worse shape than the Porsche.
Okay, now after you've watched that video clip, let's put some kinematic physics to that. Okay, so like he showed in the diagram, they had the Volkswagen Beetle. So there you got the little Beetle, drop from the helicopter towards an X. It was 1 mile above, which is 1609 meters, because we'll do that in meters. Okay, we knew that the Porsche was also 1 mile away, but horizontally, okay, it was 1 mile away, or 1609 meters. Okay, some other data that we know that it said the Beetle reaches a terminal velocity at 125 miles per hour, meaning after that speed is reached, and we'll cover this in another unit about terminal speed, but after 125 it no longer accelerated, so we know that was the final speed able to be attained, and I'll convert that and use meters per second. And we also did know that the Porsche can go from 0 miles per hour to 62 miles per hour, and that takes 3.7 seconds. And that's important too, because we can find the acceleration from that. Okay, let's first start with the Porsche, because we'll see what our findings say. So our Porsche, we want to find the acceleration first of all. So VF equals VI plus AT. Ultimately, we're trying to find the time each one should hit, make it to the X. Well, if I convert the final velocity in meters per second that it can contain, get up in 3.7 seconds, that's about 27.9 meters per second. That's what 60, what did it say? I think it was 62 miles per hour. I converted that. Equals the initial speed is 0, the acceleration we're looking for, and we know the time that it can reach that is 3.7 seconds. So I solve for A, I get 7.54 meters per second squared. Now I can take that and plug that into the distance equation, VIT plus 1/2 AT squared. Okay, what's great about this again is that our initial velocity is 0. So we have 1609 meters, that would be 1 mile, equals 1/2 A 7.54 meters per second squared times t squared. So when I go through and find t, when I solve this, I get t is 20.66 seconds. Now, that is quite a bit lower than the prediction was. I think they estimated, they thought the time would be around 37. One thing we do not know, though, for the Porsche, we do not know things about friction with the tires in the road. We don't know about air resistance as well. These are all things we're going to cover in subsequent lessons in this unit as well. Okay, now let's look at the Volkswagen Bug. Okay? All right, so we know that it is traveling in free fall. So we're trying to figure out the time. We know it achieves a final velocity at its terminal velocity, which was 125 miles per hour. So that's 56.25 meters per second. And I'm going to put that negative because it is going down. The initial speed is 0. We know negative 9.8 meters per second squared times t. Okay, so when I go and divide out, I can find the time just to reach terminal velocity, 5.74 seconds. Okay, that's just the time for it to reach terminal velocity. Now we need to find the time it takes to fall the rest of the way. Okay, well, we need to also know how long, what was the distance, because then I can subtract that from the 1609. So let's see what we can need to do here for that. We want to know the distance based on the VIT plus 1/2 AT squared. Okay, so we want to know how much distance it covered in this time above. Well, that's 0. So we have 1/2 A, which is still negative 9.8 meters per second squared, times time, which is 5.74 seconds squared. And we can see what that distance is. Distance, when you plug it all in, will equal, let's see, 161. So 161 meters is how much it's fallen in that time to reach terminal velocity. Now for the rest of the way that beetle is going to fall, it's falling at really a constant velocity. So here's where I can use my average velocity as distance over time. Okay, now that distance is going to be this 1 mile minus the 161 that it fell to reach terminal velocity, all over the time, and that time we're trying to find. Okay, and that's going to equal the average velocity that it has now reached, the terminal velocity in meters per second, which was 56.25 meters per second. So if I cross multiply and solve for t, I get t is 25.7 seconds. Okay, but then I have to go back and add in the original time it took to reach terminal velocity. And so my final time is 31.48 seconds. So with kinematics equations, we did find that the Porsche should hit the X sooner, almost, 9 seconds sooner, but that did not seem to be the case. And one of the factors we don't know with the Porsche is some of the frictional facts with the tires and the road. We don't know the effects of air resistance on that car traveling at those high speeds. But that is how you would solve a real world problem with using the kinematics equations.